Many stars belong to systems of two or more stars held together by their mutual gravitational attraction. Figure shows a three-star system at an instant when the stars are at the vertices of a 45-degree right triangle. Find the total gravitational force exerted on the small star by the two large ones. Here we have to find out, this is the based on gravitation, universal law of gravitation. Okay. And then what is the universal law of gravitation? According to universal law of gravitation, the force of attraction between any two bodies is directly proportional to the product of the masses and inversely proportional to the distance between their square of the distance between their centers. Okay. So here F is equal to G m1 m2 by r square. Okay, where m1 and m2 are the masses and r is the distance between the bodies. Okay, G is the gravitational constant. Now here, what happened? The three stars are there, and then two large stars and one smaller one. And then the mass of each large star is 8 into 10 to the power of 30 kilograms. And then the smaller one is 1 into 10 to the power of 30 kilograms. Now we have to find out the resultant force and then the direction. Now this bigger star, this is the arrangement. Okay, these three are arranged at an angle 45 degrees, 45 degrees of a 45-degree angle in a triangle shape. Okay. That means this is an isosceles triangle. We can consider it like that because the distance is also same. So the distance between the smaller one and bigger one is 2 into 10 to the power of 12 meters. And then the distance between two big stars is also, the large ones is also 2 into 10 to the power of 12 meters. Now, we have to calculate the force of attraction between the smaller one and the bigger one, and again the smaller one and bigger one. So F1 is equal to G m1 m2 by r1 square, whereas F2 is equal to G m1 m3 by r2 square. I am taking the smaller one as m1 and then the other two as m2, m3. Now m1 is equal to 1 into 10 to the power of 30 kilograms and m2 is equal to 8 into 10 to the power of 30 kilograms and m3 is equal to 8 into 10 to the power of 30 kilograms. Now R1 is so the distance is same. This is R2, R3 and R1 is this one. So this is an isosceles rectangle triangle. No, so we have we have to follow the Pythagorean theorem to find out the distance between these two. Okay, so for that this is one side and this is the other side. So to find out the hypotenuse, we have to square these two and then take the square root. Okay, so R1 square is equal to 2 into 10 to the power of 12 square plus 2 into 10 to the power of 12 square. Therefore, R1 square is equal to this one, 2 into 10 to the power of 12 square plus 2 into 10 to the power of 12 square. Okay, so R2 square is equal to this one only, 2 into 10 to the power of 12 square. And G is equal to 6.67 into 10 to the power of negative 11 Newton meter square per kilogram square. Now plug in the values here. So F1 is equal to G m1 m2 by r1 square. So here G is all the values plugging in and then simplifying, we will get the answer as 6.67 into 10 to the power of 25 newtons. And for F2 again, we will plug in the values and get the answer as 1.33 into 10 to the power of 26 newtons. Now we have to take the components because they are all having, are making it for especially F1 is making an angle of 45 degrees. And then F2, when it comes to F2, there is no angle, they are straightforward, okay, along the x-axis, this one. So we have to resolve the force into component F1x and F2x and F1y and F2y. So what is the F1x? F1x is equal to here. This is the adjacent side. No, for this angle, this is the adjacent side. So for the adjacent side, x component is the adjacent side to the triangle. So we have to take the cos of the 45, cos 45. So 6.67 into 10 to the power of 25, this is the value. So F1 cos theta. So this is 6.67 into 10 to the power of 25 newtons times cos 45. That gives 4.72 into 10 to the power of 25 newtons. And similarly, F1y. For F1y, this is the opposite side. Therefore, we have to take the sine component. So 6.67 into 10 to the power of 25 into sine 45. That gives a value of 4.72 into 10 to the power of 25 newtons. Then F2x is equal to, only we have the x component. We don't have the y component. So it is, we can directly write the value. So this is equal to 1.33 into 10 to the power of 26 newtons. Okay, and then y component is 0. Now Fx is equal to F1x plus F2x. Okay, and Fy is equal to F1y plus F2y. So we will add the values 4.72 into 10 to the power of 25 plus 1.33 into 10 to the power of 26 gives the value of 1.81 into 10 to the power of 26 newtons. Similarly, Fy is equal to 4.72 into 10 to the power of 25 newtons. Now F is equal to square root of Fx square plus Fy square. So that is equal to, plug in the values and then simplify, you will get 1.87 into 10 to the power of 26 newtons. Now we have to find out the direction, that means the angle. That angle we will get by tan theta, by using the tan theta. What is tan theta? Tan theta is equal to Fy by Fx, or theta is equal to tan inverse Fy by Fx. Now plug in the values and we get theta is equal to 14.6 degrees. This is the answer for this question. Okay. Yeah, only thing is here, these are all forces, and then you have to resolve the forces into component. That you should know how to resolve the force into components. Then only you can solve this equation. Okay. Once you know how to resolve the force into components, this will be easy. Okay. So this, hope this helps. Thank you. Bye bye.